go ahead.
Good evening, everyone. My name is Ravi. I'm dealing with physics. Before going to the topic, I will I will just about the physics. About physics, physics is one of the very easiest subject. Don't feel difficult when you learn basics of the physics. Physics is one of the easiest subject. Without knowledge, without unknowingly, we are every day we are dealing with physics like a force and a friction. Just example, take a force and friction. Without unknowingly we are applying some force on an object, right? Every day our school or colleges or in our homes we are applying some force on a objects. Okay, then friction. Friction is nothing but a opposite opposite force of is nothing but opposite force. Without force we can't run, we can't sit, we can't able to bring any objects, we can't hold any objects also. So friction is one of the important thing in our life. Okay, every day we are using the physics in our daily life. Now today we discuss the topic is work and energy. What is the work? What is the work? Work every day where you are doing so many works, not only single work. So many works we are doing in every day. For suppose example, sleeping, sleeping, walking, running. We are doing homework, writing homework. So, for suppose employees, they are doing office work in office. Everyone, they are doing some work in our daily life. But in physics, that all works not considered in as a work. Don't confuse. We are doing every day in so many works, but in physics, that not consider that and all is not a work. So what is the work? Don't confuse children. I will clear about the what is the work today in the physics terminology. Very simple. Work is nothing but force and displacement, or we can call distance also. Force and displacement. What is the force? What is the force? Either the push or pull of an object. Either push, either pull. Okay, either push or pull of an object is nothing but force. What is the force? SI unit is newtons. SI unit is newtons. What is the displacement? Displacement is the shortest path between initial to final. What is the shortest path? Like a shortcut path. Okay, initial to final point have one shortest path, shortcut, like a shortcut. So that is called nothing but displacement. What is the displacement? The shortest path between initial to final. What is the SI unit of displacement is meter. Why? Because of meter is distance. Distance how to measure in meters. So SI unit of displacement is nothing but meters. So what is the work? Come to the point. What is the work? What is the work is done? What is the meaning of work is done? What is the meaning of work is not done? Very simple. I will take one book. I will take one book. That book I will keep on the table. I will take one book or pen. Just imagine my hand is a table. This pen is a book. You just imagine. I will take one book. I just kept on the table. Now I'm apply some force on a book to push this book. I'm apply some force on this book. So what happened? When I apply the force on this book, the book will be moved from one place to another place. So one place to another place. Now I will write on one small example. This is a table. this is a table. In this table, I will kept on one book. In this place, I kept on one book. So in this side onwards, I apply some force. Apply some force. So when I apply some force on this book, so the book will be moved from one place to another place. So the book will be moved from one place to another place. So the distance is move or not? Yeah, the distance is moved from one place to another place. So the displacement, the distance moved from one place to another place is nothing but displacement. So when force is acted, when force is acted, then the body will be moved from one place to another place. This is nothing but force and displacement both will be acted. So that is called work is done. Work is done. So we can take an example. We'll take an example in our school bag. In our school bag is there. Na? So that school bag we can try to push the bag, or in our school have benches. Every day we are pushing the benches or pulling the benches. While you are push or pulling, you are applying some force on a bench, either pushing, either pulling. Anyone you can do. The bench will be moved from one place to another place, right? So that time is nothing but when you apply force on a body, on that time that particular body should move from some distance. So that means force is acted, at the same time displacement also is acted on a body, right? So that is called work is done. Very simple. When you apply some force on a particular object, that object should move from some distance. That time only we can say work is done in physics terminology. What is work is not done? Very simple. When you apply some force on a body, when you apply some force on a body, that time the body should not move. Like I take an example, wall. You apply some force on a wall, try to push, the wall. The wall will be moved. No, the wall will be not moved from anywhere. So that time what happened? Force is acted, but displacement is not acted, is nothing but zero. Is not acted means zero. So force is acted, but displacement is zero. Zero into anything? Zero. So finally, what is the work? Zero. So that is the meaning of work is not done. Now I will share one document now. Yeah, see students, I will zoom on this page. This guy is working well. He is going to office to work as it may seem. Okay, one guy is going to the office. He's doing some office work and return back to the evening to home. So this is actually we're considering the generally he is doing work, but in the physics terminology he is not doing any work. Now see here, pushing the stationary wall in the wall with a force. See here, force exerted to the right, no distance moved. Just now I said na, well we are trying to push a wall, the force is acted. Yeah, he is also acted some force. He's applied some force on a wall, but the wall is moved. No, is not move. Is not move anywhere, right? So what is the meaning? Force is acted, but displacement is nothing. So that is nothing but zero. So work is zero. Now come to that. What is the definition of work? What is the definition of work? See here. Work is said to be done. See the first line, all of you. Work is said to be done when a force acts on an object and the object is displaced in the direction of force. That only I told you right now. Yeah. Work is said to be done. When will be work is said to be done? When a force is acts on an object. When a force acts on an object and the object is displaced in the direction of force. So while we are applying some force on an object, so that time the object should move from the direction of force. Now I'm applying some force on an object in the right direction. The right direction. The object also move from the right direction. So that time we can consider as the work is done. Now see, the work done on an object is the product of force applied on the displacement. Now see here, this is a formula of work. Work done equal to force and displacement. What is the formula of work? W equal to F and S. F and S. Already I told you, right, that one. Okay, that W means work, F means force, S means displacement. Force, push or pull off an object. What is the SI unit of work? Newtons. What is SI unit of work is? Newtons. Displacement is the shortest path between initial to final. Initial to final. So that is the displacement SI unit is meter. So we are measuring the distance. So that's what the SI unit of displacement is meters. What is the SI unit of work? First of all, what is the SI unit and CGS units and MKS units? Totally three types of units is there in the physics. Okay, CGS, C for centimeter, C for centimeter. G means nothing but gram, gram, gram. Okay, S means second. S means second. Now come to that. What is the SI? What is the SI full form is system of internation. What is the SI? System of internation. Okay. Mostly in our physics, SI units is only is there. SI and CGS. MKS is not considered. Okay. MKS nothing but a SI units. That's what we not mentioned. MKS units is nothing but SI units. What is the MKS unit of force? Newton. What is the SI unit of force? Newton only. What is the MKS unit of displacement? Meter. What is the SI unit of displacement? Meter. So both units is same. MKS units is nothing but SI units. That's what MKS units not mentioned particularly. Okay, and one more system also is there, FPS. FPS. F means foot, P means pound, S means seconds. S means seconds. Okay, seconds means time measured, time measuring. Foot, centimeter and meter, this and all is a distance, length, where we measure length. Okay, pound, gram and kg, kilogram. Okay, that and all we measured with weight. Seconds, FPS, CGS, MKS. So that is S means nothing but a seconds, with time is measured with help of seconds. Okay, units. SI unit of time is seconds only. Okay, now come to the point. The unit of work is joules. That is, joule is nothing but SI units. So SI unit is nothing but MKS units. MKS unit of work is joules. SI unit of work is joules. Both is same. Okay. Here CGS unit is not there. I will tell you, just note it. CGS unit of work is erg. 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 ERG is nothing but erg. Okay. ERG. Okay. Now come to that. If F is 1 Newton and displacement is 1 meter, So then the work done is 1 Newton meter or 1 joule. Do you understand this point? No issue. I will tell you what is the meaning of 1 Newton meter. Just now I tell you force SI unit what? Force SI unit what? Force SI unit is Newton. I will share whiteboard. Force SI unit is 1 Newton meter na. 1 Newton meter. 1 Newton meter. What is the meaning of 1 Newton meter means? Just now I told you that one example. I will take one table. I kept on I kept on one book. I apply some force on this book. So what I applied? Force I applied, right? So when I applied force on this book will move from one place to another place. So this distance I consider what? Displacement. So S. So what is the SI unit of force? Newton. What is the SI unit of force? Newton. What is the displacement of what is the SI unit of displacement is nothing but meter. What is the SI unit of force is Newton. What is the displacement of SI unit is meter. So both we can F1 yes, F1 yes. So both SI units only can consider as a 1 Newton meter. This is also is one of the SI unit of work, or joules also is one of the SI unit of work. Anyone we can say is right. Most of the books there joules only they given. Okay, Newton meter. How to calculate work? Now we'll discuss how to calculate work. Very simple. Now come to the point. This is a formula. I simplify this formula. What is the work formula? W equal to F on S, force and displacement. See here, W is a work done, F is a force, S is a joules. You just noted this formula. How to find work? If in case in the question, how to find work? You just keep in brain this triangle W, F and S. You just close the W. You just close the W. So what you appear here? F and S. So that is a formula of work. Very simple. That is the formula of work. So if in case in the question find force, find a force. So what is the formula of force? You just close F here in the triangle. F is there na. So you just close the F. You just close the F. You will be what is appear here? W and S. W divided by S. This is the W division this one. W by S. So that is nothing but force formula. Like a displacement also same. Like displacement also same. Now take a triangle W, F and S. Okay, fine. What is the work formula? Just now we discussed W equal to F and S. F and S. Okay, now we should calculate work in the find work. In the question they given find work. So you just close this. You just close this. What you appear here? Force and displacement. So this is the formula of work. Now this is a very easy. No problem. Now find force. What is the formula? You just close F. what you find, that only you can just close it, you will get a that formula. Okay, then now what appear here, w divided by s. So this is a formula of force. You just substitute the values and you will get answer. Okay, now come to the displacement. Okay, displacement, on the time you just close the displacement here. So what you appear here, w
W by
w
F, sir.
w by f. So very good. So this is the formula of displacement.
Displacement.
Yeah, very good. This is the formula of displacement. So now you just substitute the work, w and f values. You will get division this one. You will get a answer. Okay,
Okay, sir.
very good. Now here, now is visible.
Yeah, we are seeing
Yeah.
whiteboard, sir.
Yeah, yeah. No, no. I share one document, sir. No.
We cannot see that. Have
Okay,
you?
okay, sir. Now I will share. Sorry.
Yeah.
Okay, now is okay, sir.
Yeah, we can see work.
Yeah. Now see one example is there in the last corner. Here one example is there. If a force is 5 newtons acts on a object is displaced through 2 meters in the direction of force. Is the meaning is force, how much I applied, 5 newtons of force I applied on a object. So that time the object move from one place to another place. How much distance travel? Only 2 meters. So what you find here, then work is done. Okay, then work is done. Now here, how much work is done here, we just calculate. What is the formula of work? What is the formula of work? F1.
Right.
Yes,
Right
F1.
on it.
Hello.
Oh yeah, sir. Go ahead.
Yeah, what is the work formula F1? Yes. So 5 newtons, you just write a formula W equal to F and S. In the F place, how much is given in that force? 5 newtons. And
5
the
Newton.
displacement how much is given? 2 meters.
2 meters.
So 5 multiply 2, you will get a 10 joules or 10 newton meter. So that is nothing but work. So that much work you are done. Okay, now work is, finally work is three types. Work is three types: positive work, negative work, zero work. How many times is? Three times. Work is three times. One is positive work, negative work, zero work. What is the positive work? Very simple. You apply some force on an object. When you apply some force on
Voice
an
stuck
object.
అవుతుంది సార్.
Now is okay. Hello.
Yeah, it is clear, sir. You go ahead.
Yeah. Okay. The work. What is a positive work is, see in the second line, the work done by a force is positive if the force and displacement are in the same direction. What is the meaning? When you apply force, the object should move from the same direction of force. Like take an example, school bag. In our homes also chairs is there, chairs. Okay, you try to push or pull on a chair or bag or anything, small things. Okay, not like a wall or car, like not big size, small things. Okay, like in our bed pillow, like, okay, so we are trying to push that object, small things, the that things will move from the same as a direction of force. So force and displacement of the object both in same direction, is called positive work. Positive work. Just now I told you one example also. I kept on one book on table. I tried to push the book. The book will move from one place to another place. So that example also is nothing but positive work. Why? Because of What is a positive work? Force and displacement in the same direction should act. So in that example, book is move from the along the direction of force, right? So which direction apply the force? The same direction the book is moved. So that is an example of positive work. Okay, very simple. What is a positive work means? Force and displacement both act in the same direction. That is called positive work. What is the negative work? Is the opposite of positive work. Okay, force and displacement are in opposite direction, not in same direction. I'm applying the right side, but I'm applying the force on an object in the right side direction, but object move from the either left side or down or upward, is not moving in the same direction. So is called negative work. Very simple. Don't do this thing in our homes or anywhere. One car is moving the our side. One car is moving the one side, one either right side or left side, any side, any direction is moving. So oppositely was standing on a car and try to push the backward direction. You try to push the backward direction. Is it not good? I'm just saying for example only. Don't do anyway this type of things. Okay, the car is moving one direction, you are standing in opposite of the direction, and then you try to push the car will be move back. No, the car will be moving the opposite direction of you are applying force. You are applying force one direction, but the car will move from the opposite direction of force. So I'm just saying one example only. Force and displacement is both is acting on the time oppositely. Opposite direction is acted. And then we can take one more example. Trolley, luggage bag. So we are going to anywhere, some relatives house or anywhere tourist places, we are taking one luggage bag, right? So at that time we can handle one trolley. Trolley is moving in. I will share one whiteboard better to understand this example. Now just example, this is one trolley. This is not like a box only, but you just example this is a trolley. Now I tied one thread here, a thread or anything. Okay, wire. Now I'm here one person. Here one person. He is pushing this direction. This direction. Okay. Now he is pushing this direction. He is applying force in which direction? This direction, upward direction. But the trolley or this box is moving in which direction? Horizontal to the plane. This is the floor. Just imagine this is the floor. The person is applying force in which direction? This direction. In this direction he is applying force. Okay, with the help of thread. Okay, on the time the box trolley is moving in which direction? Surface. So okay, surface. On the surface. Okay, on the surface the flow the trolley is moving to the horizontal to the plane. Okay, in this time force is acting in this direction, but displacement acting in this direction. Both in same direction? No, both is not in same direction. Okay, so that this is also an example of negative work. The last one, zero work. What is a zero work? Zero work is very simple. Already we discussed. We can take an example, one heavy van or car, either one van. We can take on school van. In our school's van is the, yeah, don't do this thing also, please. Okay, then take an example, wall. Better, already we discussed about wall. That's what I'm taking another. Take an example, wall. You are trying to push a wall. The wall is not move. As usually, the wall is not move. So you apply force. You applied force. You apply 10 newtons of force, but displacement is zero. Zero into anything, zero. What is the work on that time? Zero. Okay.
Zero.
Zero.
Zero, sir. Okay, sir.
Totally that time what is your work is zero work. No sir, I'm applied 100 newtons, 1000 newtons, 2000 newtons of force, but the wall
Always
is
zero.
not moved. The wall is not moved. So what? You apply force, how much is not calculate. You apply the force on the time the object should move. Then only we can consider either positive work, either negative work. Otherwise, if in case one also is not acted, not satisfied, that time is called zero. Okay, sir.
Yeah. Is it over?
Yes, topic is very lengthy,
Now
but
you can
source.
stop here. You can stop
Okay,
here. We can
sir,
continue.
source and yeah, yeah.